HVAC 360 is brought to you today by the HVAC Summer Reading Program for Kids. If the kids in your life are anything like me, they would rather chew on a box of pneumatic tubing than read the assigned classics for summer. So here at the HVAC Summer Reading Institute, we have hand-picked some new classics that are true or equals in our mind and that should qualify for credit at any school district. First up is one of our favorites, Fahrenheit 212. This is by Hugo Award winner I Am Steamy. The other selection is An Always Chilling Tale of Ice and Men by Professor Softserve. And for extra credit, we have added the heroic tale, Little HVAC Women by none other than our own Betty Smalls. I think everyone will agree that these new classics are just what our future engineers ordered. Sign up today. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping give you the best of the brightest in the field of HVAC. Each week I'm either sharing information about lessons learned in the field or talking with industry experts. But I don't stop there. I want to encourage you to double down on your weekly helping of HVAC knowledge by hopping on over to none other than HVAC360.com to join my growing community of people just like you. Where I'm happy to say that my membership site is back online and improving month by month. So what are we doing this week? This week I am going to continue. I've heard some good feedback, but I'm going to take an article from the ASHRAE Journal this time. This one is one of their standard columns. This is the IEQ column, and it talks about human performance and productivity in buildings. Now, I'm going to kind of summarize the article real briefly, and then I'm going to put kind of my 2 cents in as far as what I think about this topic. All right, so as engineers, we really work hard to optimize the energy performance of buildings. But when we take a look at it, the rule of thumb, as the article points out, for every $100 spent in an office building, $90 is going to go to employee salaries, $9 goes to rent, and only $1 of that original $100 will actually be spent on energy and utility bills. So, I mean, it doesn't take a rocket scientist to be able to understand that 15% increase in human productivity is way more than 15% in energy savings. So the ROI is so much higher. The article goes on to talk about how this performance is defined in human terms. So 3 terms that they use, and these words are used interchangeably. They're often misused. So they wanted to really define these 3 terms very specifically. So the first one is performance, and this is the degree of success people have at accomplishing intended tasks. So you can think about this as test scores. You can talk about that, older adults living on their own, their ability to prepare meals, to take their medications on time. It goes for when you talk about tasks, it covers a very broad spectrum. Productivity is the other one that a lot of people would use. Productivity is if anybody studied economics, this is about work produced per unit of time. So this is a lot more detailed. You think about a call center, the number of minutes spent per phone call. If you look at key performance indicators for businesses, what they're actually measuring to see if they're going to be profitable, this is going to be in that productivity realm. Now, they've broken out this cognitive performance as that third term. This is really kind of a subset of the performance, but it specifically focuses and encompasses a lot of the memory, test pattern recognition, that kind of stuff. This stuff that you usually attribute to when you're developing one of these tests in a controlled environment. Specifically, when we look at the cognitive performance, it in and of itself, when we look at how we test, it gets broken down into three executive functions that they go into. First was the working memory. This is the ability to hold information in there and manipulate it, to answer questions, things like that. Next is the inhibition, the ability to control your attention, not get distracted, and override habits that you have. And then the third executive function that they list is the ability is task switching. So it's an ability to flexibly switch tasks from one thing to another. And really, when you talk about developing tests, they talked about using all three executive functions to be able to simulate something in the lab environment. So now, getting away from some of these testing terms, they're really, how does indoor environment impact the design? So basically, the design can either, and this is pretty obvious, it can either help it or it can erode the performance of the occupants. Really, it pointed out that the environment should be physically comfortable. This is not a big surprise, but I'll get into that later. Otherwise, we're going to really use up mental resources trying to counteract some of the bad effects. Another thing that they pointed out was the access to daylight and the views. This is something that allows people, when they have that access, it allows them internally, to better regulate some of their impulses, to calm down, to alleviate stress. But ultimately, the article pointed out there is no one-size-fits-all for design solutions. Sorry to break this to you. But one of the possible solutions that they did bring up is that, if you since there's a lot of different things, a lot of different tasks that we do on a daily basis, you use or you want an environment, you want environment A to do task A. You want environment B to use task B, to do task B. So you have to be able to allow for a switching in environments to be able to perform different tasks. So if you just have one environment for people, that doesn't necessarily work. And that's more the more the purview of the architect. So ultimately, what they said, the key takeaways from the article is to have good thermal performance and to have space choice, to have the environmental choice to be able to switch between spaces, to be able to optimize and productively do what they need to do. All right. So that's it. Full stop for the article. I in picking this out, I always look at that rule of thumb that you talked about in the beginning. If you spend $100, $90 goes to the employees and $1 goes to the energy savings. It's like, why even, why bother? Realistically, and it's hard to get out of this mindset of we got to save energy, we got to save energy, we got to save energy. You talk about different buildings like a hospital, for instance. It is so critical that you have the environment that you want, that you disregard any energy savings that you're actually going to, that is not even on the table as far as considerations goes when you're designing a healthcare facility, because it is so paramount. There is so much at stake with getting the environment right that energy savings just doesn't matter. Which really is, kind of mind-blowing as an engineer. You want to be able to say, okay, if I'm not focusing on energy, can I actually affect human performance? Can I make an engineered design that can affect the human performance? Now, I talked about different spaces here, and like I said, that's the architect's kind of role. That's what they're doing to get different spaces for different people. Obviously, when you look at a standard office building, you're going to have conference rooms, you're going to have office area, you're going to have some areas that are for making calls and things like that. Those are some of the areas that show up that allow you to go from one area to another area and be able to focus. I've had prime examples of sitting in an open office space with, very low partitions, and somebody gets on the phone, and he's a particular loudmouth, and, he's just talking away, blah, 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 and there is no way to focus on what you need to do, and you need to be able to put on some headphones just to drown out this very loud environment. There's just some environments that you just can't work in. So ultimately, if you're not affecting the spaces, if you're not designing the spaces, and I mean that in an architectural sense, if you're not allocating space for one purpose or another, then what are you left with? How do you affect the performance of people? And ultimately, your job as an engineer kind of gets back to what your job as an engineer always was, and that's to provide a comfortable environment first. First and foremost, make sure that the environment that the occupants are in is comfortable. It really doesn't take a rocket science, and I think everybody has some examples of even being in an office personally, of if it's too hot or too cold, you're not getting any work done. Your productivity goes to zero. So being able to keep that comfortable, talk about some of the previous episodes. We talked about this radiant mean heating effect. If you can't use the first 6 feet of the exterior, 60 feet in from an exterior wall, if you can't use that because it's all glass and it's just blazing hot, that's not a good engineering design. If somebody was working there, they'd have zero productivity. So what you are supposed to do as an engineer to provide better human performance is to make sure that radiant heating effect doesn't occur. You talk to the architect. This is where you need to put your foot down and say, no, this is going to be uncomfortable. When you say uncomfortable, you can just say this is going to be unproductive. Same thing. All right, so even talking about zoning properly, making sure that everybody is able to control their own environment, that helps people. Obviously, the solar radiant. We talked about heating and cooling available when needed. This is not, if you think about some of the different systems that exist out there, sometimes there are, heating in the winter, cooling in the summer, depending on where you're living. But there are shoulder months, and usually there's some systems out there that do a systems changeover. So sometimes you get into a situation, say for instance, if it's early spring and you get a cool morning, but you've already transferred over to cooling, you're not going to transfer over to heating. You're just going to kind of tough it out. But being able to provide a solution to some of those situations where you can actively, make sure that they can, whether they need heating or cooling, they get what they get, or they get what they need so they can be productive in their space. So focus on good design, good comfort, good control, good zoning, all the very basics of what an engineer would do in the first place. Another thing that you'd want to take a look at, outside air. Obviously, outside air plays a big part of being able to, keep a space healthy. When you look at, just a general IEQ layout. Another one that's pretty big that often engineers miss is noise. Making sure that a space is not noisy. There, just like heating and cooling, if you have a noisy space, there is no way that you can focus on the work at hand. It really makes that space unusable. So you really need to focus on making sure that if there's a piece of noisy equipment, it's going to go into a space where there's transient occupants. Make sure that it's around like an elevator core or bathrooms or corridors, things like that, where you're not going to have people sitting there for long periods of time being exposed to those noises. And as just kind of a prime example, there's been a couple of cases at least that I've dealt with, where the digital scroll compressors, it's one of those devices that provides you some great partial efficiencies. It allows systems to be able to actually heat and cool better, because will be able to ride that comfort curve of a coil and make sure that the dehumidification, that passive dehumidification, is done properly. But ultimately, the coil itself, or the compressor itself rather, is very noisy, and it very obnoxiously so. There was a case where we had a chiller that had a digital scroll compressor. It was mounted on grade, and you could walk by it. It was in a secure location, but people would on a regular basis walk by it, and they go, is that done? Is that finished? Because it's so loud that it's really like, no, was there supposed to be some sort of sound baffle or something put up there? Even to the point where it could be objectionable to neighbors. If your equipment is causing you problems, it may not necessarily be all the occupants that have to put up with it, but if you are managing a space, if you're the facility manager and you have a piece of noisy equipment and all of a sudden it causes you to have to deal with neighbors, that could be a very big problem. So as an engineer, be very sensitive to how much noise your particular piece of equipment is making. And just saying, just putting on the drawing, hey, it has to be quiet or it has to be a certain decibels. It really is up to the engineer to make sure that that is absolutely possible. What that looks like. If there's any sort of options that could improve that could help you, because it's really, you really have to check it out in the submittal process to be able to understand if that in fact is what you're getting. And you really have to be the professional, be the one who takes a look at that to understand what the noisy components are to a particular piece of equipment, and be able to handle that. So that is my commentary. As much as we like to say, hey, you know what, we can do something to affect performance, it really gets back to, hey, understand what basic fundamental design is. Make sure that the space is comfortable. Make sure that it's not too noisy, that you get the right amount of outside air so it doesn't feel stuffy or get moldy, humid. Really control those conditions. Do the fundamentals, and you will invariably affect the human performance of those spaces. So you will be able to, indirectly affect the performance and get those savings for an owner. It'll make that building be extremely usable. So focus on the fundamentals. Understand what it means to be a good engineer, good design, and that's pretty much it. So that is kind of my commentary on the human performance. They have all these different tests and things like that. And, the information is great and it's useful to a point, but maybe not to engineers specifically. You really need to focus your energy first on knowing how to design well. Thanks so much for listening. I hope this is helpful. If you know anybody who's looking more information about this topic, consider passing this episode along. If you're not a subscriber already, consider going over to HVAC 360 and joining the growing community of people just like you for more weekly goodness. And lastly, I would be greatly honored if you would consider leaving me a rating on Apple Podcasts, as well as jumping over to YouTube and hitting subscribe. We offer these episodes as you could listen to them on YouTube if you want. There's not a lot of video that goes along with it, but it is broadcast on YouTube as well, just in case anybody was wondering. Well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.